Hey, everybody. I'm Allison Howard, and I am a faculty member in the Department of Psychology at the University of Georgia. I teach a lot of different courses, but a lot of them have to do with some neuroscience concepts and some anatomy concepts. And I also lead a lab and teach a course with students creating content in VR. And so over the course of the semester, this project you'll see has been a sort of prototype for my students to make their own content, and they're making things to treat test anxiety or phobia of needles or concepts about brain anatomy and so on. But this particular project that you'll see is something that was relevant to a lot of the other classes that I teach, and that is the structure of the neuron and the action potential, which is the way that neurons signal each other. Yeah.
Fantastic. So yeah, big jump in topic, which is what we love at Zoe, that we can cover a whole range of different subjects. So it looks like
Yeah,
Sil
for
is
sure.
working on getting it pulled up now. How are we feeling,
Fantastic.
Sil?
Yes, I'm in there. All right.
Perfect.
Fantastic.
Yeah, so what you see here is a sort of laboratory, and students are tasked with building a neuron from all of these component parts. And so I'll kind of try and lead you how to do it. I would imagine that students would do this when they have already learned the concept of the structure of the neuron, but yeah, you've got it. You got the axon there. And then the endings of the axon, you'll need a cell body, that big kind of bulbous structure at the back. It's kind of light pink. And that guy goes where exactly? So
Like,
you will, exactly, that's perfect. And so students will see the dendrites on those, on the neuron itself. This would be something that they would have studied before, but seeing it in 3 dimensions, we actually know from research it's helpful for students to learn something about anatomy or the alignment of structures in 3D. So they have all of these pieces, and then they would need to know the names of those pieces.
just so
Um,
that people don't feel bad, it's not my first time in the experience.
Great. Yeah, and so they can tap there to check their work, and it will show the model. So they can see what they got right, what they got wrong with the labels, and so on. Yeah.
And then I can add this. I won't be able to do it myself without
Yeah.
seeing this.
So the myelin will go on those little bulges. Yes. Perfect. Yeah, retrieval practice. Exactly. That's the idea. So to see it in 3D, to get this practice at labeling, Zoe does that really, really well. And they get a cue that they've gotten it right, but they can also check their answers. And the next stage is going to sort of test a concept that they also would have learned in class, and that is the fact that between
Oh,
Oh,
I've
yeah.
lost Allison's audio. Is it just me? Can
No,
other
no,
people hear Allison's audio?
I can't hear her
I'm gonna say
anymore.
hi. No, I cannot hear you either, Allison. I don't know why.
and now I hear y'all. Can you hear me?
Yes.
Yes.
Okay. Okay, so the concept here is that in between neurons, they are going to communicate chemically, and within a neuron, it communicates electrically. And so this is another bit of retrieval practice. Students would lay out a sort of circuit, a line of 3 neurons, one after the other, and practice the concept that between neurons, it is chemical with these speakers, and within the neuron, the communication is electrical. So we have the beakers symbolizing chemical communication. Yeah, and these just go in between neurons. And then the little the little lightning bolts are our electrical symbols. I ask this question on tests all the time, and students don't remember it. So this is a little bit of practice, and you can also tap to check your work.
Yeah, I will just cheat
Yeah.
my way.
It's fine. Yeah. So they have the key there and they can check their work.
Okay.
And that's it for this stage, essentially.
Nice. Cool. Let's go to the next stage.
Okay, and in this next stage, it is sort of essentially showing them zoomed in a little bit more of where those chemical and electrical communication signals are happening. So the action potential is graphed there at the bottom. If you press the red button on the left, in fact, either of the red buttons works. Yeah, then that will show you where the chemical and electrical signaling is occurring. So they look up at the neuron and they see this is chemical signaling. It's happening around these two spaces on the neuron, so they can see it. They can see it in 3D space, indicating where those signals are happening. And then the other red button will indicate and show where exactly the electrical signals are happening. And that is a bit hard to see on my screen, but I think it's much easier to see in VR in between the segments of myelin. So this is the place that they need to know electrical signals are really important in the neuron itself. And so across each of these stages, students are kind of zooming in more and more and more on the neuron and on the process of these ions flowing. And I think this is our second to last stage. So we are going to zoom in even farther. Here we have a reminder of where we are looking. The action potentials involve the movement of those charged particles, and then you can tap to zoom in. And we created this asset of a giant neuron that you can then tap to slice it in half. In fact, tap the text box. Yeah, exactly. And so this is showing that movement of ions a little bit more up close and personal. And you can tap the button and ions flow in. And as you are doing that, what you'll see is that the charge in this graph on the right-hand side changes. You can tap the next button to reset the ions, send them back where they originally came from, and then watch how the charge changes. Again, you can do that as many times as you like. So the ions move and it increases the voltage of the cell, and so on and so forth.
Cool. Nice.
And then the last stage is zooming in one final level, and that is to show students that those channels that they have been studying, they come in these different shapes, these different configurations. And so when ions try to move in one configuration, they can pass through, but in the other configurations, ions cannot pass through. So this is an important piece of like learning 3D layout of the structures, is to see them moving in real space. So you can, or virtual space, I should say. So if you press that button and then look up at your axon, you'll see the ions move. And the next button, they do not. They try. They would like to move into the neuron, but they cannot move. And then the final, they also cannot move. These are concepts that students would have already been learning. It's just a matter of seeing them in 3D space. And this is the end of the experience as I have it for now. But I have big plans to take this farther, and I want to actually have students build layouts of ions in the appropriate places to see if what they would predict would happen, will happen, with the movements that they have learned should happen. Can they put pieces in place? Because actually having the practice of laying out the parts of the neuron in their appropriate locations, I think is going to be a good reinforcement for the concepts. So.
Absolutely. I love it, Allison. I think this is such a cool way of simplifying quite complex concepts. As someone who hasn't taken an anatomy or a biology class in a very long time, I found this easy to understand, which really speaks to how well you crafted this, and surprisingly beautiful as well, I thought, seeing all of the ions sparkling for us.